So I know yesterday I had a question about the previous day's work, and when it came to this little table and like how to read that table. So this thing's not. So in the past, I guess if I like try to, we're used to just making like a regular like little XY table, right? Where X is your input, and then you put it into the function, and then you get your Y out. So on this one though, instead of just writing it for one function, it's actually writing it for 3 separate functions. So it's kind of like taking all 3 of those tables and then putting it into one. Does that make sense? And then X and Y intercepts, we can actually look at a table, hopefully, and figure out like where our X and Y intercepts are. If it comes to like your little coordinate plane, right? And if you want to find your y-intercept is where it crosses the y-axis. And when we cross the y-axis, we know that our x value is always 0. So when I look at my table, wherever my x is 0, that's going to tell me where my y-intercept is. So for our first function, our y-intercept is at 2. On the second function, our y-intercept is at 2. And on our last one, we're at 0. So then when it comes to x-intercepts are where we cross the x-axis. And when we're crossing the x-axis, we know that our y value is going to be 0. So then if I go through my little table and I look for where this y equals 0, and y equals 0, that's going to tell me where my x-intercepts are. So on our first graph, our x-intercept is at -2. Our second function, our x-intercept is at -1. And on the third one, our x-intercept is at 0. Does that help clarify that a little bit on that table? Alrighty. So today, I know it's Friday, but we're going to try a little something new. Not all review. We did some review yesterday, right? So we're going to bump up and look at that section 1.2, which is on functions and their graphs. So, and I'm going to say, like, ever since you've been in Algebra 1, your teachers always try to talk about these things called functions, don't they? Yeah. Anybody got a good definition for a function? Mm-hmm. So we know in a function, for every x value, there is only how many y values? Only one y value. So a lot of times when it comes to functions, we refer to them as being one-to-one. A function is one-to-one. Which means that ultimately that our x values cannot repeat. So if I give you guys some points, We know a point is an xy coordinate, right? So if I gave you guys the point, I don't know, let's say 0, 9, 10, 6, and I'm just making these up, 20, 10, and 30, 13. And I'm going to say that I want to keep like all of these points together because that's what we're talking about. So a lot of times we then throw brackets around all of these points. So it says like all of those points are all together somehow or another. So if I just look at the points, I can make a determination if this is a function or not. So is this a function? So our definition of our function is for every x value, there's only one y value. So if we look at our x values, what's our x values on this point? 0. What's our point here? X coordinate? 10, 20, and 30. Do they only have one y value for each one of those? Yeah. Does our x repeat? No. So guess what this is? This is a function. So yes, it's a function. Do you guys remember domain? What values do we talk about when we're talking about domain? Would that be our x values or our y values? X, yep. These are our x values. So if I wanted to know the domain for my function, it would just be all of my x values, right? So what were my x values? 0, 10, 20, and 30? And if we're talking about domain, then we might as well talk about range. I so wish there was microphones out in the audience so like that the video could pick up all of your guys' enthusiasm. Good job. So my range is going to be my y values. Okay. And I can look at all of my coordinate points, and can I list all of my domains? Oop, I don't want to erase. So what do I have? 9, 6, 10, and 13. All right. Got some more questions for you. So, is this a function? What if we had 6, 1, 6, 2, 8, 3, and 9, 4. And these babies are all together. Is this one a function? No. And why not? Because for a 6, we have a value of 1. And for this 6, we have a value of 2, right? So it's not 1 to 1. Because the definition was for every x value, there was only one y value. And for 6, how many y values do we have? We have 2 of them, right? So our x's are repeating, so can't be a function. What about the points 1, 6, 2, 6, 3, 8, and 4, 9? Would those be a function? Yes, right? Because there's nothing about saying that our y's can't repeat. Our y's can repeat. But for an x value of 1, we only get a 6. We don't get anything else, right? For an x value of 2, there isn't any repeats, right? So it's a function. Can you notice anything about these two sets of points? Is there anything they have like in common or, you know? Yes. Yeah, they're the flips of each other, right? If you take your x values and your y values and you flip them, anybody know what that's called? Starts with an I. Inverse? They're the inverse of each other. Yep. And we'll get to some more of those too. So yeah, so when you switch x's and y's, it's the inverse. So yeah. Alrighty. You guys good on picking out if something's a function or not? Real quick, if I ask you guys to graph a function, and if I give it to you as like negative 3x plus 6y equals 2, do you guys have a whole bunch of methods in your head on ways in which you could graph it? One thing you could do is you could solve it for y. So you'd get to where like y equals, and you'd actually get it in y equals mx plus b form, right? So if I wanted to get y all by itself, I don't know, whichever way you want to do it, right? You can like subtract 2 over, subtract 6y over, and then divide by 6, right? It's one thing you could do. The second thing, how many points make a line? 2 points, right? So you can find the x-intercept, then find the y-intercept, and then now you have 2 points, and then you can connect those 2 points. Do you know how you'd find the x-intercept? What do we know about the y value for the x-intercept? If we go back up here, right? When it comes to the intercepts, like the x-intercept, your y equals 0, right? And if you're looking for the y-intercept, your x equals 0. So if I want to find my x-intercept, I'm going to put in y equals 0. So I'd have negative 3x plus 6 times 0 equals 2. And then you can solve it for x. And if I want to find my y-intercept, what do I know? X is going to equal 0. Okay. So then you would put in 0 for x plus 6y equals 2. And solve it for y, and then that'll give you your y coordinate. And then you can connect those 2 points. You guys thought you were done with algebra class, didn't you? Alright, let's do some evaluating because we gotta spice it up a little bit. So when we're given functions, we can figure out different values that fit within our functions. So we call this evaluating a function. So we know from our past experiences, there's different ways like that we can write functions when it comes to that function notation. Right? So back in the olden days when you guys were just, wee little Algebra 1 students and sometimes some Algebra 2 students, when it came to writing a function, we would write it as like y equals 2x plus 1. But now that we're in the FONSI math class, instead of writing as y equals, what else could we write it as? You guys remember like the f of x equals 2x plus 1? Right? And we like writing it in this notation because we're going to plug in an x value, right? And then we're going to put it into our little equation over here. And so the way that it's written, you can always know what x value and like what y value you have in the function. So it automatically will show you your input and your output. And we don't always have to use f. We can use whatever letter we would like. So feeling a little spunky today, so we're going to go with h of x instead of f of x. So let's say I have h of x equals x to the 4th minus x squared plus 1. Cute little function, right? What's the degree of this function? It's a 4th degree. Yep. How many terms does it have? 3 terms. This would be our first term, second term, third term. All right. So when it comes to evaluating these, granted they could either give us like the x value or they can give us like what the whole entire function equals or the y value and then solve it. So if I asked you guys what is h of 2, what do you think you're going to do? So we did have h of x, but now we have h of 2. So what got replaced or substituted? You got a 2 in there for the x. So when it comes to our function, we're going to put 2 in for x. So now we'd have what? 2 to the 4th minus 2 squared plus 1. So what are we going to get? H of 2 equals, what do we got? 16 minus 4 plus 1. So h of 2 is going to equal 13. So now you know your input or your x value or your domain, right, is 2. And then you're going to know your y value or your output or your range. And technically you know what point to graph, right? If you were to graph it, you would be graphing the point 2, 13. Okay. What if I wanted you guys to find h of negative 1? What are we going to do? Put negative 1 in for x. So I'm going to put this one in parentheses just because it's a negative. So I'd have negative 1 to the 4th minus negative 1 squared plus 1. So you guys do the math and I'll do the math and we'll see if we get the same answer. Did you guys all get 1? Yeah. So we just got to make sure that when we're looking at exponents, like of negative numbers, right? So you're not taking the 4th root of 1, right? You're taking that 4th root of -1. Yep, good job. All right, but maybe we don't want to leave it as numbers. Maybe we want to put in, you know, variables. We could do it that way too. Oh, I'm gonna, can't go too far. What if, let's say we had h of -x. What would we do for h of -x? We just put in -x for our x's. So we'd have -x to the 4th minus -x squared plus 1. So if I take -x to the 4th, what do you think I'm going to get? X to the 4th minus -x to the square, is this going to get me back down to x squared, plus 1. And I could get really fancy. What if we had like h of 3x? So I'm just going to put 3x in every place there was an x. So now I'm going to have 3x to the 4th minus 3x squared plus 1. And then now we got a couple little properties that we got to use from our last chapter. Because we got it to the 4th power. So who gets the 4th power? Everybody. So what's 3 to the 4th? 3 times 3 is 9. Then this 3 times 3 is 9. So 9 times 9 is 81. Then x to the 4th minus, what do we got to do with our square? Share with everybody. We get 9x squared plus 1.